Okay, hello everyone, and welcome back. Today we're going to start standard deviation. Okay, it's an important concept. We've talked a little bit about it already, but we're going to go into it a little further. All right, today's objective, we're going to quantify and analyze the spread of data from the mean. Remember, we were looking closer at the median, where we used the IQR, which measured spread around the median. Well, now we're going to measure spread from the mean. All right, today's essential question. Is there a way to measure how a set of data varies from the mean? Well, it turns out there is. All right, now we've learned already about two measurements of spread. The range, which is the minimum minus, or the maximum minus the minimum. It's the biggest number minus the smallest number. All right, we looked at IQR too, which is the middle 50% of the data. It's the third quadrant minus the first quadrant. All right, well, now we're going to look at standard deviation. It measures variance from the mean. How spread out the data is. We call this a low standard deviation if it's narrower, high standard deviation if it's more spread out. Now, when data is symmetric, a bell-shaped symmetric curve, it's said to have a normal distribution. And we're going to look close at normal distributions late this week and early next week. But it's important to know what one looks like. And we used one last week when we had the 2 dice activity and rolled them. We created kind of a normal symmetric distribution. A set of data that looks something like this, where there's 1 7 and 1 13. You see that? But here there's 2 12s and there's 2 8s, and 3 9s and 3 11s, and then 4 10s in the middle. That would be a bell-shaped curve. Okay? Guys, when data is normally distributed, the most useful measure of spread is standard deviation. All right? When you have a normal curve, and you get that a lot in the real world, okay? Standard deviation, again, it's a measure that shows how data varies from the mean, and it quantifies it a little bit. So as you can see here, we can measure 1 standard deviation away and 2 standard deviations away. And just to review, guys, the mean, it's the average. It's the sum of all the point values divided by the number of points. Again, we've worked with that. That's just a review. Guys, standard deviation has a great big long formula. Now, you can calculate it using a table. It takes a while. We're going to use Desmos or a graphing calculator, okay? I just want you to understand it comes from somewhere. All right, and you might need to know that standard deviation, it's the square root of the variance. This is a square root sign right here, all right? To get to the standard deviation, we're taking the square root of the variance. This is called the variance inside here, okay? Now, actually, there are 2 formulas, all right, for standard deviation. There's one for an entire population, and one if we're only taking a sample of the population, a part of the population. But for this class, we're only going to use the total population. We're only going to use that particular standard deviation calculation for the entire set. Just a quick example here, guys. I'm trying to prove a point here. Look at these 2 brands, brand A and brand B. Take a look at these data displays. These are both histograms. The mean is 1,200 hours for both. But as you can see, B has a bigger standard deviation. It's more spread out. The standard deviation here is over 90. We're up here in brand A, the standard deviation is 75.5. All right, so brand A is considered more predictable because it has a lower standard deviation. It is less spread out. In other words, if we randomly chose a value from that set, the probability is it would be closer to the mean than it would be if we randomly chose a data value from the other set. Right? That's what that means. It's more predictable if it has a lower standard deviation. All right, guys, that's it. Remember, again, two things. Standard deviation measures variance from the mean, and standard deviation works best with a normal distribution. That's when we really want to use it. All right, there's 4 vocabulary words. They're right there. And we'll go through them with the warm-up, okay? All right, thanks for listening.